So cryptography, you might find this topic not interesting or boring if you are not not introduced this subject properly. And for people who are not in the field of networking or network security or some kind of security engineering role, this topic will be a quite challenging topic, and yeah, it will hammer your mind, if not explained properly. That's my experience with this subject, is because I come from an engineering background. My graduation was in electronics and communication engineering, and I was pretty much more inclined in to the communication segment of my engineering course. And even though if I was an engineering student, it took me a while to get a grasp over this topic. And so I can understand people who are not coming from an engineering background or an information security background, how hard it will be for them to understand this topic. So in this video, I will decode cryptography. I will give you 1,000 feet overview. And hopefully this video will be a one-stop video for you to understand what cryptography means, what is symmetric and asymmetric cryptography, what is key wrapping, what is digital signature, what is digital envelope, and what is public key infrastructure. If not possible in one video, I may split the whole topic in 3 videos. So stay tuned. And let's start the journey of cryptography. I think it's wise to cover only a few section of cryptography here, because the length of video will be too much. I will better split this whole topic to explain authentication, to explain confidentiality, non-repudiation, and other stuff like digital signature, digital envelope, key wrapping, and PKI. I think I should cover in 3 separate videos. So this will be the first video, and yeah, let's start. Let's go to a message M. Let's take a message M. What is a message? It's just a digital piece. It's the information which we want to move from some place to some other place, like point A to point B. Here, point A and point B are actually the computer system, right? So there are 2 users. Let's make a story. This is a user A, and this is a user B. This is how I draw users. Now, this is the message M, and this guy A wants this message to send it to B. So, of course, if these 2 guys are very near, there is no question of, or there is no need of any discussion that how message can be transferred. It can be just handed over to the person B. But when we are talking cryptography here, or we are talking information security in terms of CISSP, what we appreciate is that we are talking in terms of a public network, which we call internet, right? So there is a message M, there is a user A, there is a user B, and there is a public network. And this public network, with the name public, it means that it's insecure. It's not secure, right? If the network is secure, then again, there is no need of any discussion. A can send the message as it is over the secure network, and we will get it. So this internet is basically insecure in nature, right? I will just put this in bracket, or non-secure, or you can say there is another common word which is called untrusted. You can't trust this network, right? Now, let's introduce one more character here, which is a user C. And this user is basically an adversary. It's an attacker, or a bad guy, basically. Attacker, whatever word you want to have here. Now, what will happen? What's the common problem? The problem is that if this message is going to travel to B, there is a high chance that this C will sniff this message and will read it, right? Now, to stop this, we have to do something so that either C can't intercept it, or if C can intercept it, it can't read the message, right? So if C gets this message and it reads the message content, what has happened? So we always think in terms of CIA, right? So CIA, confidentiality, integrity, availability. The whole objective of this video is to see these terms in action, right? So if C reads this message, what has happened? What has happened? We'll see that out of all these three, the thing which has got impacted is confidentiality. So confidentiality is compromised. And there are two things which has happened here. The one thing, how this is compromised, one thing which has happened is called interception. And with the interception, what has happened is called disclosure. I hope you're getting a sense of how these words are taking shape of different characters in the story, right? So A actually sent a message to B. It was supposed to be with B, and it actually reaches B. I'm not saying that it has not reached B. M has reached here, but M has also reached to C. Now, since C has received, C is not the intended recipient of this message. So this reception of the message by C is called interception basically. So C has intercepted the message. With this interception, disclosure has happened. The message is disclosed. And what is compromised in my CIA triad is confidentiality. So confidentiality is compromised. What could have stopped this? The only thing which could have stopped this is what we call as encryption. If we would have encrypted this message, then this disclosure would have been saved, right? It could have been saved if there was an encryption, right? So do we think that the availability of the message is compromised? No. Availability is intact. Message is available to both B and C. Do we think that the integrity of message is compromised? No. Integrity is also intact because the same message M has been moved to B and C. So this is just an example to understand the term interception, the term disclosure, and the term encryption, right? So encryption is used to uphold the confidentiality of the message, right? This is also which we should have in our mind, that whenever we use the word encryption, it should ring a bell of confidentiality, right? So encryption is mainly used to uphold the confidentiality of the message. Actually, encryption is also used to achieve integrity as well, right? We will see those examples coming up, but the prime purpose, the primary objective of encryption is to uphold confidentiality of any message. This is what I have understood from CISSP study actually. So yeah, so this is the scene, this is the setup which we will be discussing moving forward. Now, how we encrypt a message, right? So there are many encryption methods. There is a field which is called cryptography, is actually the subject where we study about how we can encrypt a message. And there is a different term used, cryptanalysis, which is basically the reverse of cryptography. It's about decoding the cryptic message, decoding the encrypted message, and finding the plain text message. So this M is called plain text, and this, if it is encrypted with some key, the resulting message will become the encrypted message, right? So we will move forward with this terminology, with this concept, with this example in the next video, where we will be understanding the different method of encrypting the message. We will not dive into the techniques of cryptography, like what are the different modes of encryption and all those things, but we are just developing this story to put you the concept of authentication, non-repudiation, encryption, digital signature, digital envelope, and PKI, so that you see those characters in action, right? As I said in the beginning of this video, right? So let's meet in the next video. And again, best of luck for your CISSP exams. And if you have any specific question, comment, feedback, suggestion, whatever you feel like, you can comment in the video. Okay? Thanks for watching the video.